Okay, so now what we're going to do is we're going to look at some set operations. So let's just start off by talking about the complement. All right, and before discussing the complement, let's just define the universal set again. All right, so the universal set is just a set that includes all objects being discussed in a particular problem. All right, so if we were to say A had elements A, B, C, B had elements D, E, F, then our universal set would consist of all the elements A, B, C, D, E, F. And so you can see all of these are found in A and B, and the universal set includes all the objects that are being discussed, but you can even have more, right? So the complement of a set are the elements in the universal set that are not in, let's just say, set A. Doesn't necessarily have to be set A, it can be any set. So, and the notation is, let's just use A, right? Is A with this little apostrophe, or mathematically can be called prime, but we call this complement. So let's take a look at an example. Let's say the universal set has elements 1, 2, 3, 4, 5, 6. Let's say set A has elements 1, 2, 3. Set B has elements 2, 4, 6. We're going to find, how about the complement of A? Once again, the complement are the elements. Complement are the elements that are in the universal set that are not in set A. So what I like to do is I like to list my elements in U. 2, 3, 4, 5, 6. List my elements in A. 1, 2, 3. And with this information, we should be able to find the complement. All we do is cancel whatever's the same. They both have 1s, they both have 2s, they both have 3s. What we're left with is 4, 5, wrote my 6 too soon. 4, 5, and 6. These 4, 5, and 6 are the elements in the universal set that are not in A. And now let's go ahead and find the complement of B. Once again, we always relate it to the universal set. Right, our U has 1, 2, 3, 4, 5, 6, but now we are looking at set B, which is 2, 4, 6. That should be enough information to find the complement. And we do the same thing, cancel, cancel, cancel. We're left with 1, 3, and 5. That is our complement of B. So that is how we find complements of sets. Let's now go ahead and talk about the union. the union of, let's say, sets A and B are all the elements found in set A or B. And the notation looks like a capital U, but just a little wider spread. Okay. Reads union. So example, A has elements A, B, C. B has elements C, D, E, F. We want to find A union B. Once again, this reads union, and union is the set of or the set of all the elements that are found in A or B. So it's really easy. When we find the union, all you have to do is list all, right? This just means list all, but do not repeat. Right? So we have A, B, C, D, E, and F. See, these are the elements that are found in A or B, and we just don't repeat them. All right, because we see C is seen twice, but we just write it one time. And now the intersection is what we'll look at last. Intersection is defined as, let's just say, the intersection of set A and B are the elements that are in common. Or other words, the elements found in set A and B. All right, so let's take a look at our example. I'm going to use the exact same sets that I used earlier. All right, so once again, A equals set A has elements A, B, C. Set B has elements C, D, E, F. Now I want you to find, oh, and I forgot to add the notation, sorry. The notation is this U upside down. So again, reads intersection. So now we're going to find the intersection. This symbol is different. It's just what is in common. We can see both of these have C. And that is our answer. So one thing that I want you to notice is that both of these examples, we use the same elements, but the symbol, right? That symbol definitely made a difference in our answer. Union, we listed all of them. Intersection, we only listed one. All right. So really understand the difference between them. Now what we can do is we can do some set operations. with union, intersection, and even the complement. Example. Let's say our union equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say A equals 1, 2, 4, 5, and 7. Let's say B equals 2, 4, 5, 7, 9, 11. I want you to find, how about we go with A intersecting B complement? So we know what A is, right? A is 1, 2, 4, 5, 7. But we need to find B complement. And in order to find B complement, we list everything that's in our U. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We list everything that's in B. 2, 4, 5, 7, 9, 11. And we cancel. They both got 2s. They both have 4s. They both have 5s. They both have 7s. They both have 9s. Oh, I'm sorry. I'm missing an 11 in my U. And they both have 11s. So the B complement, what am I left with here? A 1, a 3, a 6, an 8, and a 10. So it's 1, 3, 6, 8, and 10. I'm just going to bring this down. Bring my set operation down. All right. So now I'm using this operation, which means intersection, which we saw earlier. Intersection, what's in common? So now what's in common with this and that? See, they both have a 1. Looks like that's it, huh? They both have a 1. There's no 2. There's no 4. So this is your answer. So a nice example of a set operation, and there's many more to practice. And if you have any questions, please let me know.